Calculate the area bounded by the functions y equals cosine of x on the interval from negative pi, which is less than or equal to x, which is less than or equal to pi, and the line y is equal to 1/2. In other words, this shaded region that's provided here. The first step in this process is to determine these points of intersection, or the x values of those points of intersection. It appears that it's going to be at -1 and 1, but let's double check that through solving an equation. We have y is equal to cosine of x and y is equal to 1/2. So we can take this 1/2 and substitute it in for y in our first equation. Therefore, we have that the cosine of x will be equal to 1/2. So the question is, where is cosine of x equal to 1/2 on the interval from negative pi to pi? Well, this ends up happening at x values that are equal to positive pi over 3 and negative pi over 3. So those are going to be our lower and upper bounds for integration that we have here. So let's set up our integral. So we're going from negative pi over 3 to pi over 3 of cosine of x minus 1/2 dx. And we're doing that because the cosine curve is above the line. So now let's integrate. The integral of cosine is sine of x minus 1/2 x. And then if we evaluate that from negative pi over 3 to pi over 3, we are going to have the sine of pi over 3 minus 1/2 times pi over 3. And we're going to subtract the sine of negative pi over 3 minus 1/2 times negative pi over 3. Okay, so the sine of pi over 3 is square root of 3 over 2 minus pi over 6. Then we have minus the sine of negative pi over 3 is negative square root of 3 over 2 plus, because I have minus a negative here, pi over 6. And now if we distribute this -1 that's outside through to both terms, we'll have the square root of 3 over 2 minus pi over 6 plus square root of 3 over 2 minus pi over 6. And that's going to simplify to square root of 3 minus pi over 3. Now all of these values are decimals, so let's get out our calculator and substitute those in there. So we have square root of 3 minus pi over 3. So that's equal to about 685 thousandths, or answer choice B.